It's a general program. You can take the Truss contain 1000 element and 1000 nodes. It's up to you. Subscribe this channel. Hello, this is a structured program used to analyze the truss by using finite element method, which is also called the stiffness method. This is all the coding of the program in the MATLAB. So now I am executing this program. So see what will happen. First, it shows me some instructions that all the forces and the dimensions are in the same unit. It also gives me example that in SI system all the forces must be in the kilonewton or in the newton, or and the length dimensions must be in the meter or centimeter, whatever you take. And it also gives me a restriction about this program, that this program is only for such type of trusses at which forces are acting on the nodes, not for the settlement case, and not for the such type of trusses at which the forces are acting on at any distance on the element, and not for the such type of trusses where the increase in length on the element occurred due to the effect of temperature. It also gives me some requirement before executing this program, that first you have to assign the number of nodes, and you have to calculate the nodes coordinate, and you have to calculate the a and e value for each member. Now I am taking a simple truss and gives the program input. So see what will happen. I have a truss which have 3 nodes. It contains 3 elements. The coordinate for node 1 is 0 0, coordinate for node 2 is 10 0, and coordinate for node 3 is 10 10. Now the program is asking me where the element is number 1 is connected. My element number 1 is connected to the node 1 and node 2. My element number 2 is connected with the node 2 and node 3, and my element number 3 is connected to the node 3 and 1. Now the program is asking me, is there any support at the node 1? Yes, I have hinge support at the node 1. It also gives me a description. If hinge is present, so write H. If roller is present, it gives me 2 condition where x is equal to 0, so write R1, and B condition is and the roller where y is equal to 0, write R2. At the node the third part of the description contains if there is no support, so write, and I have a hinge support at node 1, so I am writing capital H. At the node 2 I have roller support where x is equal to 0, so I am writing R1. I have no support at node 3, so I am writing capital N. So it is asking me to write, is there external forces present at the node 1? No, I have no any force present, external force present at node 1, so I am writing 0 0. Similarly at node 2, but at node 3 I have 2 forces, 2 in the 2 kilonewton force at the positive x-axis and 1 kilonewton force in the positive y-axis. So I am executing this program. Now it is asking me, is there is a value is constant or not. My for each element of the truss my value is different, so I am writing n. Now I am individually taking the input. I am giving input. My a value is 100, 1. For the second element 50, 1. Syntax is very important in the MATLAB. If you get the answer, otherwise it shows error. And into sqrt comma my modular elasticity value is 20. Wow, it is giving me a output. So output of this program contains degree of freedom. First it will shows the degrees of freedom. In which way? The first column contains nodes. Yes, the matrix contains 3 nodes. It shows it all automatically developed the degrees of freedom number in the x and y and the y axis. At node 1 I have 2 degrees of freedom it gives the number 1 to the x-axis, to the x-axis degree of freedom, and give the number 2 to the y-axis degree of freedom. Similarly, at the node 2, it gives the number 3 to the x-axis degree of freedom and 4 to the y-axis degree of freedom, and so on. That calculate the local stiffness metric for each element and the global stiffness metric for all the elements, and combine all the global stiffness metrics and convert into the one and master stiffness matrix, which is a whose length is 6 into 6. It also gives me an unknown displacement. On the truss, displacement occurred due to the action of the applied forces or external forces. On the my truss, there are two external forces applied at the node 3, so it gives me a degree displacement occur at that node. It also gives me a degree of freedom number, which I am telling you at the start of the output. 0 displacement occurred at the node 3. At the node 3, no displacement occur means there is a support present, so it will prevent the displacement. There is a 0.4 displacement occur at degree of freedom number 5. So see, where is degree of freedom number 5? Degree of freedom number 5 is located at the node where node number is 3. Node number is 3, and degree of freedom number 5 is at along the x-axis. So what are the other outputs? It also gives me a reaction forces along with its degree of freedom numbers, and the main purpose for stiffness element method is to calculate the internal reactions produced in the element due to the external application of the external forces. So it gives me the main input, which is the internal reaction forces. It also plot the diagram, or the black color truss shows the undeformed truss, and the red dashed line truss shows the deformed truss. This is a very good program. If you want this program, so I am giving my contact detail at description of this video, so you can like this video. Thank you for watching this video.